Well, I could not do the review for exam 1 in one whole stretch for lack of time, so I'll do it in little bits and pieces. This is part 1. It's just one problem because a student has requested for the problem to be done, and it's a kind of difficult problem, and I'm putting it up there even before the assignment is due so that people who make use of the YouTube will have a certain advantage over the others. Now, this is the problem. It talks about, let me clean this up. Okay, it talks about an owl carrying a mouse to the chicks in its nest. It is 4 meters west and 12 meters above the center of the 30 centimeter diameter nest and is flying east at 4 meters per second at an angle 31 degrees below the horizontal. If it accidentally drops the mouse, will it fall into the nest? Okay. Now, let me get this diagram. It's kind of tough. It is not drawn to scale. So you can already see the diameter of the nest, 30 centimeter, and it's 4 meters towards the west. And it is flying at 12 meters. That's the height. And its velocity is given by that arrow. It's 31 degrees below the horizontal and it's 4 meters per second. Okay, so the velocity is 4 meters per second. And it's at 31 degrees below the horizontal. Okay, you can break that velocity into two components as we usually do. The horizontal component is 4 cos 31, which we will call Vx or Vox. That is 3.43 meters per second. And the vertical component is 4 sine 31. This comes out to be 2.06 meters per second. All right. The idea is we have to calculate the time that the mouse takes to fall through a height of 12 meters. Alright, that's the first thing, the time. So we're only talking about the vertical component now. It's the y direction, so you only take the vertical component of the velocity, which is 2.06 meters per second. The acceleration is 9.8 meters per second squared. The vertical displacement is, of course, 12 meters to the nest. And we are trying to find the time. So the equation is delta y is VOT plus 1/2 AT squared. And on substituting, you get a quadratic equation. That is the problem. So there's more math in this question than physics. Rearrange this to get it in the format of a quadratic equation. If you remember it, it is AT squared plus BT plus C is equal to 0. Now, the solution is given by minus b plus or minus square root of b squared minus 4ac by 2a. Yes, you got to know this formula. That's why you had to study algebra before you took this course. So now you can see that a is 4.9. Right here, a is 4.9, b is 2.06, and c is negative 12. So when you substitute it into that formula, it's minus 2.06 plus or minus, you got 2.06 whole squared minus 4 times a, which is 4.9 times C, which is negative 12, whole divided by 2 times 4.9. So you have to calculate this very carefully. Square the 2.06, you get 4.24. You multiply that, it's going to become positive because there are two negatives here, so it will become positive. And then add the number under the square root. And when you take the square root, you actually get plus or minus 15.47, but we're going to only consider positive because time cannot be negative. So we're only going to take negative 2.06 plus 15.47. That's what you're going to see on the other side. So then you would get 1.37 seconds. Once again, remember, we're only taking the positive values because time cannot be negative. Now, since we know the time for the mouse to fall down, we can calculate the horizontal displacement, which is the displacement along the x-axis, by using the formula velocity multiplied by time, because remember that's the only formula you can use because velocity is constant along the x-axis. So now you get x is equal to VOX multiplied by time. VOX was 3.43 and the time is 1.37. So you get 4.69 meter. Now the total distance is only 4.3 meter. So now it goes more than 4.3, therefore it will fall beyond the nest and it will not fall into the nest. Poor chicks, they're going to go hungry. Now, one more thing, just to check how many people are watching this video, will you please send me an email saying that you have seen the exam review video part 1. Send me an email message and I'm going to give you extra credit on the exam. Thank you.